that should be a bit better. It should be audible now. I'm just going to turn that down a little bit. Turn myself up, and that should be, yeah, it should be coming through nice and clear now. Just checking. It's on -3. Yeah, that should be good. Okay, going to turn the music down just a little bit. Turn it up there. Okay. Yeah. Testing. That should be good. Okay, we should have some good levels now. So yeah, hi everyone, welcome back. It's been a while. I checked, and the last one of these was the 30th of November in 2024. And the stream felt a bit dead, sorry about that. But there was a reason for that, and that's because we got stuck on trying to make the floor not look terrible and to get the 3D effect. So if I do trunk serve, we should be able to see where we got to with the game. And I will bring that in. There we go. Do a refresh. And so we got to here, we got our little guys walking around, and we got this with like the sort of beginnings of an altar, and then the floor, and it just curved, and I have no idea why. And it got me thinking that we should probably abandon the idea of trying to do 2D graphics, because doing the 3D projection of that is significantly harder. And so I've actually spent the year away having a look at WebGL and how to create a WebGL context within Rust using Yew. And so the plan now is to actually make it a 3D game, much like the game that we're trying to emulate, which is VirtuaCop. And so that's going to be largely what we're doing today, is just trying to get the WebGL 3D context, and then ideally we'll get a cube, but we'll see. But once we've got that, I think that it should actually open up a lot more, and then we don't have to worry about calculating the coordinates for each of the different graphics and things, which is honestly quite annoying. Just realized I'm going to start recording, so I forgot to do that. Yeah, so that's what we're going to do today, is get that WebGL 3D context going. I will be copying code from a different project that I've been working on, which is the kind of the basis for this. I will try and write all of it. There's a couple of bits that I will just be copying and pasting, and I'll leave those to the viewer to go and view on GitHub when I publish the code. Those are around the model manipulation and the shaders, or the initial shaders. At some point, I'm hoping that we're going to be able to get into and write custom shaders for, particularly for each of the little guys, and also to add some magic effects to the fantasy theme. So let's go and have a look at the code and where we got to. This is a comparison of the code that's there. You can see from the last time we were just messing around with trying different things. There's logs all over the place. It was a mess, and yeah, trying to do 3D maths on the fly it turns out quite difficult, or it was probably prone to causing lots of errors and things. So we won't be doing that. Right, let's have a look. Gotta get the other projects going. That's not what I wanted to do. There we go. Right. Okay. Yeah, I have the other projects up, and so I can now use this as a reference. So I think to start with, we're probably going to end up throwing a little bit of this code away. Mostly the stuff in here, because we want to. Yeah, we want to get rid of all of the enemy stuff, and yeah, all the rendering. So let's go through and have a bit of a purge here. I'm actually going to take a new branch, feature, going 3D. Right, going 3D, there we go. Okay, so we've got our canvas, that's all good. That's as it should be. And we've got our mouse events. going to, so walls. I actually don't think we want to do walls now. We just want to do, so one of the advantages with going 3D is that rather than having to do each wall individually, we can just do a skybox and basically exist within the skybox, and that will be our room. So I guess we're going to add that in. Oh gosh, yeah, the back walls. Yeah, that's a mess. Right, so skybox, and for now we'll just make it a back wall until we get the actual 3D context out of the way. Get rid of that, get rid of the walls. Okay. Why doesn't that like that? Oh, skybox, that's why. Yes, name. And I think we'll also probably just get rid of all this stuff as well, so we can start from a fresh context. Yeah, in there. Do that. Lovely AI helping us out there with saying helping us to comment stuff out. So we'll keep the mouse move stuff because that will be useful. We'll be using that. So I'll put clear, get rid of that. Yeah, in fact, let's just get rid of all of this stuff. It's still on the branch, so we can always check back in with it. That. Okay, and this is where we now need to make our big changes, where we're going to add the 3D, but let's get rid of this first. Let's get it so it compiles, and then we'll start making those big changes. So check firewall strike. I don't think we need that. I'm going to comment. No, I'm going to delete that. We should delete that. Start again. Does it compile? It does compile. Okay, so now we have so now we just have a blank page, which is great. So that's what we want to do. And let's have a look at our other projects. Sorry, I'm just cross-referencing on the other screen. Make sure I get the syntax right for this. So we're going to want to do some imports at the top. We'll probably want to gut a lot of the stuff. Yeah, there we go. We're not using any of that. We'll leave glue console in as that, but then we'll reference glue console log. Okay, I didn't like that. Oh yeah, because we've got our back wall. Okay, let's get rid of the back wall then. Just get we're going to be getting rid of that anyway, so it's not an issue. Okay, so we want to pull in some stuff from WebSys. HTML canvas and we're replacing our canvas rendering context 2D there with the 3D one. Probably put that inside there, tidy it up a bit. Single line, great. Okay. Yeah, I think that's all we want for now, and we've got our messages. Do want to have a render message. Oh, we've got the render message. It's there. Okay. Right. Okay. Our properties are empty. We've got our callback. Oh, this is great actually, because we've got loads of stuff that we needed already. So then I think it's just a case of the rendering context. So I'm going to go down to fold the updates. Fold the view. Yes, this is what we need. So we want to get the canvas itself is self canvas cast. Yes, that's correct. And then we're going to copy. I'm just going to copy this code in. So there we go. We've got our WebGL context. Shoved a load of stuff in there as well. Okay. Right. Then we want to self.width and self.height. Do we have a width and height? We don't. So we want game width and game height, I think. Those are F64. Oh yeah, we're casting. Okay, so game width and game heights. We can play around with these actual properties later. Oh yeah, we'll definitely get rid of those. So I'm going to leave that in there so that it reminds me to actually put it back in. This was how we were mapping our coordinate system when we were working on a 2D. I think that will still be useful now. So actually, I'm going to change this to C so that we don't get confused between the self-canvas. Yeah, change all of those. Some C, okay, self-canvas, C, C. Okay, so we need a canvas and a GL reference. I'm just going to check what type those need to be. The canvas is going to be a node ref, and GL is going to be an option, OpenGL. It's all good. Just double checking our canvas. Yes, excellent. And the canvas node ref. How do we do node ref? Cool, so we're going to set that for none. Oh, we actually already had canvas. Have I got canvas in here twice? I do have canvas in here twice. Okay, let's do that then. Right, so back down to the, as you can see, it's trying to recompile and just failing at the moment, but we'll get there in a second. And that is because we haven't cast this properly as we've come to grab it. So we want to sorry, I'm trying to find the okay, right, rendered. Yeah, okay, that's why. So we need to stick this inside one of the yew handlers, which is actually not in the render here, it's in up here. It's an extra optional function that you can have inside, so it's rendered. Get rid of that. We grab the reference to the node element, set self-canvas is equal to some C. Why doesn't that like that? Ah, yeah, because it shouldn't. Yeah, hang on. I think that needs to be an option. And we'll just set that to none. And then once the page is rendered, that's when we'll actually grab the link to it. So, oops, inside or rendered. Okay, excellent. And then it sends our thing, as you can see, project game message render. I suspect this has been passed somewhere else. I'm just going to have a look where that would have been passed. That's the handler. There we go. Right. So yeah, instead of launching the render loop in the create, we're going to wait until the page has been rendered first, meaning that if first render. Okay, yeah, first render is part of that. Cool. Yeah, okay, so that. Then inside our render, we actually want to get rid of this stuff here. So we don't need to do that because we'll have the reference to it. But first of all, we will do a match self.canvas. This is just to check that the first render has actually been performed at this point. I don't think we'll just do that and none return. Yeah, so we'll post a little glue console message there to do that. And our game update is just doing this. Cool, I think we're Okay, just checking the music's still running. Yes, it is. Excellent. Cool. Just checking in on the stream quickly. Awesome. Right, so okay, so that should hopefully be at least able to compile. Let's go down to the bottom and find out why it's not compiling. Be something, oh, an undisclosed limiter. Oh, great, I've missed a bracket somewhere. Okay, so I think I see it. There we go, should do it. Scroll down to have a look. Okay, nope, still. Okay, 5 previous errors. Okay, yeah, this was okay. Game height is 32 and game width. Okay, self.noderef, that's actually canvas. Okay, what have I done wrong here? Let's come and have a look at that. Okay. Right. So yeah. So I missed something. Copying. Okay. So what have we got? So what's okay. Canvas node ref. Okay. Right. The node ref is actually different. So do need a node ref. And the node ref in here is going to be the default. What does it want us to do there? There we go. Yep. And then canvas actually needs to be of type. It's an option of an HTML canvas element. There we go. Okay, and I think this is going to cause a problem because I think we need to turn this on in the features. Yeah, and that needs to be node ref. There we go. Okay, closer now. Okay, no WebGL rendering context in the root, and for that we now go to here, and might as well take out the 2D rendering context because we don't need that anymore, and then I'm going to move down to the bottom because it begins with a W, so it should be at the end. Okay, just wait for it to rebuild. Okay, still getting errors. Okay, yep. Okay, let's, where's that? It's characters, so, get rid of player, characters, just getting rid of the modules rather than deleting all the old code so that we can easily, okay, lightning bolt, that is in assets, assets. Might be it. Are we? Oh, looks like it's compiled. Okay, nice. So there's our game. We can go back to the root just to show you. Remember, we created this. My plan now is to, at some point, have the HTML menu over the top and then have like a 3D something going on in the background, like some sort of scene. But for now, we're going to experiment on the actual game page there. And of course we have a blank page because of course we do. So let's go. Yeah, just closing down everything else. Okay. And actually we'll get rid of that and we'll go to game. Go to the render. Okay, so the next thing we want to do is set the background color. So after we've got our, okay, we first need to get hold of our GL rendering contexts here. Yep, so self-GLs. In fact, actually, let's make that a match of the GL context. Yeah, as we're actually referencing that, even though one is derived from the other, we should probably reference those. So then we're going to clear the viewports of that. Make that game width and game heights. Set color. Well, let's not make it black. Let's make it green so that we know when we're there. Actually, just a slightly nicer green. Let's go 0.8 and make that 0.2. 0.2 should be a slightly muddier green. Then, because we will use them later, we might as well add the depth test and the clear for the color bit mask. Then that is everything. Great, so let's go and have a look at our codes. It's still black. Why is it still black? Let's go and have a look here. Okay, the canvas is the right size. There's nothing on the console. Okay, just going to check that we've got the message in here. And so we are receiving that message, so it is calling the render frame, which is good. So, oh, now it works. Okay, it's come back in its screen now. So there we go. Great. So this is our 3D context. We're going to do all of our 3D drawing. So I did mention at the beginning that I think we're going to cheat ever so slightly and just copy. I've got like a model class, so that's going to go inside a new module, which we will call model, and in here we will add a mods.rs, and in there create model.rs, model. So that we can pull that in from anywhere, and in here we will add mod model. There we go. Right, so the content of this I will, as I say, I'll share to GitHub, but essentially it allows you to read in a GLTF model, which is like it's a way of storing a 3D model in a JSON string. We'll have a look at some of those later. It also handles the loading and everything of shaders and stuff like that and sticks them on the model. It's writing this by hand would just be me copying tediously from everywhere. So I won't do that. The other thing I'm going to take is a camera, because that's always useful when you're loading, and this has all of the matrix transformations. Anyone that's familiar with excuse me, anyone's familiar with 3D models will know the matrix transformations and things like that, and how complex that can be. And so we're just going to start with this. Essentially, you can set the position, you can set the target, and the up is calculated internally from there. So we'll save that and save the model. Okay, it still compiles, which is great, even though it's just not trying to compile the camera. Oops. Mod camera. Okay, now we're getting some errors. So we've got no GLTF JSON, which is actually as expected. So do cargo add GLTF JSON. Check if there's anything else that needs to be brought in. So just recompiling those new libraries. Okay, some other stuff not running, that's great. Just uniform 3G, no method found. Okay, that probably means we need a bunch of stuff, and we do. There's a load of extra stuff in the cargo.toml. So it's not just the WebGL rendering context, we need WebGL buffer. Oh, I don't like that it's got the it's just so it matches the rest of the file. Okay, texture. Image element, canvas element, image data. Yeah, I think that's good. So let's have a look and see if that solved our issue, the missing items. Okay, we're down to 14 errors, that's good. Okay, no closure in here. Closure is not a dependency. Okay, there's a couple of things missing. Okay, yew. Oh, we can actually update to version 2.2. Yew-rs is on 19. Definitely bring in Serde JSON because we're going to need that. Just get rid of the version number there. Going to bring in Serde as well. Extra Serde libraries. I suspect we're going to want these as well. Put those in. Okay. You know what? I'm just going to actually copy all of this stuff from here. There we go, because I know that these ones work. So undo that. Those. Something tells me it's still going to complain about the closure. No, okay, I think it's in the WASM bindgen library, which it probably was complaining isn't installed, but it will be now. Yeah, there we go. It's in there, so I think it's part of Prelude. Get the closures. What have we got? 1 error, no, 10 previous errors. Okay, let's kind of look. Okay, yep, we're also missing the utils class. That makes sense as well. Okay, I'm just going to copy all of... Oh, well, actually, we won't need these because these are all for 2D stuff. So I'm just going to drop in the utils file. Four warnings, that's good, good start. Base 64, okay. What do we need that for? Right, okay, yeah, internally all of the... Yeah, so these are some other functions that help with GLTF files and reading the data from them. So it gets, like, all of the polygons inside are encoded in a binary format and then base 64 encoded and then dumped into the JSON file. We'll see some in a bit when we have a look at our first model. That's all good. That means we just need to get base 64 standards, which do cargo add base 64. Try trunk serve again. Okay, and we need Euclid as well. Oh, it looks like we're compiling. Awesome. Yep, so still green screen because we haven't actually done anything, but we've put our models in now, meaning that we can add stuff. So now I'm going to go and try and find a model that we like. I think a cube is the most logical first step, but let's have a look at... I've got some other projects which are available on Codeberg as well, which cover the let's go do that. Okay, yeah, they cover the rendering and viewing of them. So I'm just going to see if I can find it. There we go. Okay, so look there. And this is actually a desktop app. I hope to release the actual binaries for it at some point. It's not really finished yet, but it lets you kind of have a look at models that you created. And then I also have another application I've written with GLTF Exporter. So you remember that when we were doing 2D pixel graphics, I was drawing my own sprite sheets and things. Now we can create, and I will be creating on stream at some point, the models by using composites and looking at and using and writing raw polygons as well, and then compositing different blocks on there. Just waiting for this app to compile. Hopefully I can show you some of the models from a different project that I've been using. It's still just building. This is the actual thing compiling at the moment. It's like a big thing. All of the code for this is available on Codeberg, and I'll link that in the description below after the stream when I tidy up all the links and things. Cool. How long are we going for? Half an hour. Okay, great. Still just building away. Just hope I've got some like actual models that people will want to see. I think I've got one of a tree. I'm hoping the tree is going to be there. It lets you select different shaders as well, so you can try your models with shaders, and you can update the shaders, and it'll update and reload the app, which is quite cool. Yeah, I'm hoping to eventually, because they're all written with the same sort of technologies, so it's all like a WebGL context, hoping that we can put it online as well and have like an online 3D modeler with a viewer that then lets you download the GLTF, which I think would be quite cool. Okay, nice. So we have this. You'll see similar kind of green. So we've got some models here. The cube I wanted is the cube texture, and then cube texture for the vertex shader and for the green shader. And I actually have a dice skin one, so it can scale up. The movement's a bit limited at the moment, but you can like zoom in and out, and you can rotate your thing as well. So this is with a texture laid over the box, and I think yes, it also does the back buffering as well. So this is going to form the basis of what our view looks like, because we're going to be inside the box looking down the box, and we can also skew it. So that's great because it means that we've got a model that's ready to go. So this is cube texture square, which I have in my project. Copy that into, yep, that's a good question. How do we load this? So the easiest way is to create a new, let's close all of those assets. Yeah, we'll create this and we'll just call this skybox. Remember to put it in here, mod skybox, and we'll comment out all of these so that we can just see our skybox, and then in main re-enable the assets. Oh, I didn't like it. Why didn't I like it? No point in utils. Why is it trying to do lightning bolts? Because I didn't save this, that's why. So it's still trying to link to those other files now. Okay, great. So now I need to find the other code that I'm doing. And this is where we're going to get to the point where I actually start writing some code as well. So we are background, right. So this needs to be a pub struct skybox. Oops. And most importantly, it's going to have a model. We also need a place to store this, and I'm going to put this in the source Tory folder. We don't have a source Tory folder, okay. So in here, I'm going to put assets GLTF so that we can link in our skybox, new model, new skybox. Excellent. It's almost got there, but I'm going to do let model equals new skybox. This model, and then we're going to just put our set GLTF. It's going to be equal to include string. Yeah, actually, let's have a look at the. Yeah. So this is our box, and we can see that it gives you like the minimum and maximum variance. And this is like GLTF. You can look it up, I guess. It's this representation of having a JSON file with all of the data for the 3D model in it. So here we have the URI, which has all of the data. As you can see, it's 1,584 bytes long. And that's all of the data of the models of the triangles that make up the cube that I just showed you, and it also has all the UV vector points, which is how you tell your texture, which is just a flat file. So in fact, I'll find the texture. Where is it? I'm looking in the wrong place, that's why. It's called Dice Skin, and it is available. I'm going to put this in just so that we can I'm going to put this in textures, or just texture. Okay. Yeah, so you'll see that the components of the model are such that you have to map these coordinates on for this flat image onto the different sides. So every side is on here, and we're actually pulling the information from each of those locations. Again, this is like a standard thing. If you've seen 3D modeling before, you've almost certainly come across this. At some point, I hope to make a video on how this actually works, and how you can go about moving the coordinates about and changing things to suit your needs. Because you can even have like the same texture, and you can just smack it on each side. You can also do crazy things, have variations and stuff. So yeah, that's so these are the two things we're going to have. But I think today the ultimate goal will be able to set up the camera and to have it looking down a long corridor with the dice skin. If we have enough time left, or if I have the energy, then we'll try and add some different textures in so that we can start to shape the room as we had before. So the first thing we're going to want to do is actually set up the camera. That goes in the, oops. Pages, game, yeah, so we want a yes, the easiest thing I found with this is to have a view manager that handles a lot of the stuff. So we'll view manager, and then our game will have a view manager object on it. Cool, yeah, and the view manager doesn't exist yet. Manager. Just ignore the suggestion there because that's not very helpful. But our view manager will have a camera in it. And the camera, we will need to tell it where to import from. So use create model camera. Great. Okay, we're still failing because this doesn't know. Let's push those back together, put that together. Let's create pages view manager. Let's found it. Okay, and that is not public. Or is it? Oh, it is public. Why is it complaining? In there, maybe. Okay, let's go have a look. Oh yeah. So view manager new, and we want to also go and implement that function there. So we're going to implement view manager. Oops. View manager. Oh, there we go. And we want to do let camera equals camera new, and we're going to camera move camera to 0.0. We will go to so now we have a decision on where we want to make the floor. I think I'm going to make the floor 0, and then so we'll go up from there. and we'll say, so we'll put that 1 in the air, we'll make the whole room 2 high, so then we'll should be in the middle. And then Zs, we will make -1. And, oh, yeah, we have to make it mutable in order to be able to change it here. How long do we want the corridor? Let's say we'll make the corridor 20 long, so we'll actually make this -9. And then that needs to be camera. Yeah, so push the actual camera. Why doesn't it like this? Oh, because I've got too many variables. There we go. Okay. Camera look at 0, 0, 0. That makes sense. So it's just looking at the ground halfway down the room. And then we'll set up to be the Y coordinates so that whenever you have a camera, you have to tell it which way is up so that it knows how to rotate in the around the Z sort of axis as it's looking down. Otherwise, it could end up upside down and still be in those coordinates looking at that thing. So you have to tell it where to go up, and that's what we're doing there. So we also need to add a couple of extra things. Do we? No. Do we? Yeah, I think we should. Yeah, we should. Might as well put the updates. So, and the update, I'm just going to copy from here. And this is where we need the, do we need now? Yeah, this is where we handle our updates in order to, okay, yeah. So we're going to add a first update boolean here. And it's going to be true. And then we will, inside here, say if self.first update, then self.first update is false, and self.last update is now right because we haven't set the camera. So what this is doing, and I realize we also need to add instance, is it's tracking like the last time that we entered the function to do the update. Excuse me, sorry. In order to keep track of how long it's been, to calculate the delta from the last update. If you don't track the delta, it means that if your frames come in irregularly, you end up with like really juddery kind of movement. Whereas what this will do is smooth it out over time, so it's based on a function of time. And actually, we're going to store the delta as an F64. So yeah, that delta is 0. Then right, if self.last updates is greater than now, this is in theory an impossible position. I have come across it during testing. I don't know why, but this, yeah, there we go. That last update is also not on there. So last update. What do we want last update to be? F64. Oh, and we also need to pull in our WebGL context here. That's there. Yeah, sweet. Just checking against the list of variables to make sure we don't bring anything we don't need. So other than that, okay, let diff equal now minus last update. Then the delta is going to be, I've not seen this function before. What does that do? Give a description, or is that just a made up thing? No, it's a AI hallucination. Okay, so this is diff as f64 over 1,000. Why do we, that doesn't need to be cast as an f64. What's going on there? Right, self.uTime, and uTime is important because uTime is going to be the thing that we pass to all of our shaders, meaning that we can have time-based shaders, which we will cover in a later stream. Time factor. Actually, we don't. Okay, I'm just going to copy these in. So one thing we do need to do is update the camera with the screen dimensions. This is in case we resize, which of course we haven't added yet, but it means that we don't have to worry about it later on. Then call self.refresh. Self.camera.refresh. And we pass self.delta as the most recent delta, and self.last update is now, so that we store the previous time that we've done that, and we move on. So that's that, and then we also need nothing. That's it. That's what we've got. Oh yeah, create width and height. I'll take those from here. Width 32, go, and width 0, height 0. And we need to pull in window for this, which we'll do at the top by doing websys window. So, oh, someone dropped in and then dropped off again. That's cool. Cool. So I'm sort of assuming that most of the views for this come after the fact anyway. Or at least that's been how it's been for previous streams. So next up we want to get our model in there. And use that. Go. So there's a couple of things we need to do. We'll go back to skybox, wherever it was. Skybox, there we go. Oh yes, that's right. Okay, so now we need to set GLTF, include string, .assets, skybox, scene GLTF. Okay, it's just me, just hallucinates all sorts of stuff. So you want to go back up twice. Oops. Assets, source, back to top. Then we go into assets. Then we go into GLTF, and we're going into. Going to rename this to Skybox. Do I want to do that? Yeah, let's rename it to Skybox. And then let's do this in here, Skybox. Okay, cool. It needs to be mutable for a start. Oh, right, yeah. needs to be a string. Cool. The name internally within the model object is just used for identifying. There's nothing to stop you having all your models have the same name. It just means it's easier to debug, so you can put like debug stuff in there. So we're also going to need our shaders. Here, create a folder for shaders, and I'm going to steal the texture shader that we had before. Oops. And just dump it in. I'll have a brief look at it. Like I say, it's going to be all in the thing. So just dump these in here. So the cube texture, basically we have to set the texture on the uniform, and then we just pull the coordinates straight out. That's the fragment shader, and the vertex shader does all of our calculations based on the camera. So that's important. We're going to have to pass the camera to this, and it will figure out all of the different components that it needs in order to project the objects within the world correctly. So skybox. Okay, and we do model.set fragment shader. So frag shader to be include string. So what this does, the include string, it's a macro, which means that at compile time it dumps the literal contents of this file into this function. And I found it's quite an efficient way of doing that. If you try to load your assets at runtime, particularly if you plan on, as I do, putting this inside a Tory instance, it means you then have to set up the back and forth and handle the incoming data. This is much easier, it just gets compiled straight into the binary or the WASM executable, so you don't have to worry about those things. So we have assets, shaders, cube texture dot frag, because it's the fragment shader, and then do the same for vert. Not do that. Vert and set vert shader. Cool. Okay, it doesn't like this. It means it probably can't find the expected string. Oh yeah. For some reason I made the string. Okay. Yeah, for some reason I made the arguments strings instead. So there we go. Now we need to add an update function. Oops. One of the patterns I like to use is to basically always have an update and a render, and then you don't have to worry about the contents and stuff. So inside the update, we have to check the model. Self.model.is ready to load. This is for when you have an asynchronous callback. It actually doesn't matter so much now, because we're not loading our fragment shaders or our shaders and our model asynchronously, so we don't need this. But this was designed to be able to allow that, so that you can set any of those items at any point. Then when it's ready to load, you just update it in the update function. So self.model.setup shader. This is what does the actual compiling of the shader. Oh yes, and we have to pass in yeah, does that mean? Yeah, okay. So we need to pass in the GL context, a width and a height, so that it knows how to render those. We call the update, and then go to the render function. This needs to take an argument of time. Make an F64 and a camera, so that we can pass the camera to the shaders. And these also need passing on to the camera. And we'll need to import our WebGL context so that it knows what type that is at the top. Okay, excuse me just a second, I have to change the battery in my hearing aid, which is a ridiculous thing to have to say. Here again now, that's great. Okay. So that might be good. We do have to set a texture. I've realized that yeah, okay, so we also, oh, why doesn't it like this? The update needs, there's no model update. What's going on? Why? Yeah, we don't need to update the model. Okay, in the model render. Okay, yeah, this was a mistake I made a while ago and forgot to carry forward, or forgot to fix. So the should be function render. This needs to be an F64. And then where do we actually use the time? Right, yep, and it's because the uniform must be F32, that's why. So we'll cast it there. Otherwise we're just going to end up swapping backwards and forwards. So that's the model. Don't need to update. Oh yes, forgot to finish doing these. Right, self model.load textures. That's when we set textures and self.model.load setup. Okay, oops, turn there. And we also need to set the texture, which just need to look at it right. So let's text base 64. Let's call it B64. Equals okay, general purpose standard encodes. Question is, has it got it right? It has not, because that is, but it was close. It was very close. And then we want the data URL. Yeah, so what we're doing is we're reading the image in as bytes and encoding it as base 64, so it's a string. And then, as you can see here, we're setting the value to be like the MIME type in here and pushing the data in. And then finally, we're going to self-model set texture data URL. And then we also need to set the scale. And we're going to, I think we said we're going to make it 20 long. And so let's make it 5 wide. Oops. Set scale. There we go. Yeah, so 5 wide, 2 high, because we're at 1, the camera's at 1, and then we'll make it 20 long, meaning that we're at -9, which should be near the back wall, looking down. So that's good. And then we can set the rotation. We don't actually want to, but we don't want to move it anywhere, but we'll set rotation to be 0, 0, 0. Oh, yeah, I think we'll do that. Okay, why doesn't it, no set texture. Sorry, called the function the wrong thing. And it's complaining that we don't have the encode, which is, that's a fault of the import. So, new method, new encode for general purposes. Yeah, we're missing a trait from something. Okay. Ah, there we go. Okay, we're missing an import, that's why. Yeah, that was it. We were missing pulling in the base 64 engine. So, okay, cool. So the only thing is we aren't calling the update and render functions from our main game. So from here, I think we can pass the pass that. There we go. Right. So yeah, we're passing the game width and game heights. What is? Yeah. Okay, and from there, now we're going to pass self.gl as ref. Nope. What we're going to do is actually get the GL context here. GL context there, and then we'll just pass GL through to that. Okay, it doesn't. Can't borrow self as mutable because it is borrowed as immutable. It's because of that. think we don't actually need this because the view manager does all of the calculations for us, and that's what I was doing before. So let's just update the view manager directly from here. Okay, function update is private. Well, that is a problem. We'll want a render. Oh, there's no render. Oh, that was silly. Nope, don't want to be doing any of that nonsense. And then from here, self model dot render with the stored view time and the camera. Great. Okay. Let's see. Expected one, I found 3. Is that because the view manager update doesn't take a width tonight? Yeah, that's why. Actually, why are we even passing the GL context in here? I thought it needed it. Ah, yes, I know why. Because updates. Oh no, wait. Got a little confused now. Yeah, skybox. Did we create a skybox in the game? I think we did. No, we didn't. So where is the skybox? I think maybe we haven't instantiated it yet. Yeah, I think that's why nothing's been called. We've got one. So, okay, that, because we're not rendering any models. Yeah, in fact, we don't need a view manager render there. We do need to update it. Self.skybox.update, there we go. Yeah, and self.skybox.render. We'll do our renders actually after this stuff. Get rid of these comments, it's a bit misleading. What is it hallucinated here? Oh no, okay, no, that is correct, but we need to get the view manager view time needs to be public so we can get it. Oh, delta is private. Why is that not? Oh no, it is delta. Yeah, so delta is the difference between from the last frame, and the U time is the total time. Yeah. Oh wait. Okay, that should be F64, not 75. Oh, we're actually not using the delta yet, so we will just underscore that. Okay. Skybox. Okay. I will be back in a few moments. I just need to take a short break. Yeah, we'll crack on with the stream and hopefully get the remainder of this model showing. And then I think we'll probably call that time. But Yeah, be back soon. Okay, and we're back. So, right, we were doing this. That's not compiling, I think. Oh no, it's compiling. Okay. And here's getting an error. Okay, so we've got an error here. The specifier end was a bare specifier. Relative module specifiers must start with /. So, not sure quite what's going on there. Is it in our skybox? Is that what the issue is? Okay. Yeah, this is a really obscure error. Yeah, I've seen this before. So this is because the rendered WASM doesn't start with a relative path. I don't really know how we can best address that. It's weird because this page works and this one doesn't. So what's going on there? It does say relative should start with /. That should be working, which implies that something isn't compiling properly. So I'm going to go basic root and just start unwrapping the. Let's try getting rid of the render. See if that was the issue. Nope, that wasn't it. The updates, view manager. Get rid of those. Okay, so we've got our green back again. So we'll add the view manager back in, see if that compiles. Okay, so it's the view manager that's the problem. Let's just go look. The update function. Okay, I'm going to compare this to my one that is working. So first update, last update now, that's all the same. See what that does. We'll just stick a console login, see if that gives us anything else. Nope, so it's not getting that far. Stick these now in. Should hopefully. Okay, so something's going wrong here. Why? Okay, the end is a bare specifier. What the heck does that mean? Do the update on the. Yeah, so this is okay. So this is working. We've got our green screen back again. Not sure why it doesn't like running the view manager update. Let's have a look. This is very strange. I think I know why. So, and yeah, gosh, this is a weird, right. It's because we're missing a feature on the imported instance. It's actually crashing on this line here. So we need to add feature into instance. Actually, I'm just gonna copy paste from here. There we go. So it's because we don't have the WASM binding feature enabled on View Manager. So if we add this back in, hopefully, okay, it needs to pull those features in. I'll leave this up here. Ah, that was a weird, obscure error. Hey, there we go. And we're now getting reports from the View Manager and Screen Dimensions, which were the debug statements we put in earlier. Get rid of those because they'll just chew through rendering time. So we save those and add the skybox render back in. Okay, well, this is a good start in that we're sort of getting somewhere, but our box is still too high, so I think we need to scale the skybox to gonna make it 4 high. And there we go. We're now inside our cube. It does appear to be slightly wrong, so I expected this to be lower to the ground. So I'm going to just double check the camera positioning, the default camera position. What happens we go? Ah, yes, we never moved our, right. So, and now you can see this looks a lot better. The reason was we never moved our skybox. So we, as well as scaling it, we now want to model.set position. And we want it to be 0 across. We want it to be, because we're making it too high, so we're going to set it, sorry, we'll make it 4 high, so we want to move it up because it's centered either side of the 0, and then 0, 0 on X, on the Z, sorry. And then we need to move our camera back to where we were, so it's 4 high, and we're going to go 2. And there we go, we're now in the middle of the room, I think. I want to go 1. Just seeing which one looks better. I think that looks better because it looks, we're standing on the floor, it's quite a high ceiling, and then there's a long room. So there we go, this is where I wanted us to get to with our 3D model. So we're now looking down a static model in the room. We have a camera, we have our skybox, and next time we can start adding some actual models and things like that in. If you've enjoyed watching the stream, please feel free to send a like, leave a comment, anything you'd like to see. And we'll get back to decorating our dungeon room and adding monsters and adding the game mechanics back in as well going forward. But yes, happy 2026 to everyone. I realize that that's quite late in the year to be saying that, but obviously we've been away for a while. And yeah, if you want any, particularly if there's anything in here that you'd like to see explained better, or you would like to see made into a full YouTube video, like how to go about setting up a 3D context from scratch, what the camera does, and like how all the maths in that works, and the models and things, then yeah, drop a comment on the video and let me know. But yeah, for now, I'll wish you all a good day, and I hope you have a great weekend. Thanks, bye.